Hey, so we're going to finish up this module in this video. I realized after I was done recording that I stopped in the middle of a section, so section 2.2, but I did finish up to the last homework assignment. So now we're going to start 2.2b. So I will share my screen, and this one is very important. It looks very similar to stuff that we've done already with these word problems. However, you can tell, or these get a little more complicated, and that's why this section is more important than what we've talked about in the past. This is why we're hitting it again. So here, 2.2b, I wrote that already right here, 2.2b. We are going to translate the following English phrases into algebraic expressions. So first of all, you'll notice no capitals, no periods. These are phrases. It also said it was an expression. So we know that these are not equations. These are expressions. Oops, something is going on with my computer and I can't see my screen. Okay, I'm back. All right, so we have these expressions here. I'm going to erase extra lines. And so I've talked about the words sum and difference before, and I've mentioned just with arrows that those words change the word and. So we really want to keep track of where the word sum is and where the word, or difference, and where the word and is. So here we have the sum of 17y squared and 19. Sum means addition. So I'm going to take 17y squared and 19 and put a plus sign right there in the middle. Okay, we've done one like that before. But now it's going to get a little trickier. So I'm going to go to C and then B. And if you just kind of look at C and B real quick, read through them, you can see that they are almost identical. They have all the same words, but the words are in a different order, and that's going to be important. So here on C, it says the sum of 5 times m and n. So sum right there. There's our plus sign, and wherever the of is, so this is going to be the first part, and this is going to be the second part. 5 times m and n. That and is splitting that up, and the sum of tells us where to start, and then the and tells us where the second term is. Now let's look at B. Similar, but the 5 times comes in front of the phrase the sum of. So the sum of m and n is just m plus n. But we are doing 5 times that sum. So I need a 5 times, and you can put 5 dot, or you can just put the 5 next to the parentheses. It's 5 times the sum, 5 times the addition. Whereas the part C says the sum of the addition of 5m and n. Okay, so last but not least, we have, and I'm just going to kind of cross this out. Didn't quite format the way I wanted. I'll put it up here. We're not getting rid of it. I'm just trying to keep it all together. And so it says the difference of, and so difference is going to change the word and into subtraction. The difference of 2 times x, and the and splits it up, and 8. 2 times x and 8. And in this example, and is where the minus sign goes because we are using the word difference. So sum means the answer to an addition problem, and difference means the answer to a subtraction problem. So that, and then we always use the word and to change for the sign. Okay, looking at some more, we have some, oh no, we just have expressions still, but a little lengthier problem, a little word problem. So I'm actually going to draw a picture because I see we're talking about a rectangle. So I'm going to draw a picture of this, and I always mix up the length and the width. And it doesn't really matter, just call one of them length and one of them width. Whichever one you want, because we could always turn the rectangle sideways if needed. But it says the width of a rectangle is 6 less than the length. So we know that word is means equals from the last video. Width is going to be W. Width is W equals. And then finally it says 6 less than the length. So I'm going to do, remember that less than, that than switches the order of length and 6. So it's going to be length minus 6. So the width is the length minus 6. It is 6 less than the length. Finally, it says let capital L represent the length of the rectangle. So the actual thing you would type into the computer, if this was a problem on the computer, you would type in capital L minus 6. I am not particular, like in terms of your handwriting. So if this was something you were just writing out and you put a lowercase L, that's fine. But sometimes the computer can be a little picky. So I just want to point out those little nuances because I don't want you to get them wrong on a problem that you actually know how to do, but maybe you just typed in the wrong way. All right, one more similar where we have a word problem that we're going to write an expression for. And so here it says Lauren has dimes and nickels in her purse. The number of dimes is 3 more than 7 times the number of nickels. So that's going to be our clue. That's our sentence that we're looking at. And it says let N represent the number of nickels. So number of dimes, I'm going to call D. I always like to find the verb in the sentence. So we have our is right here. So D equals, and now we just have to figure out that last part. 3 more than 7 times the number of nickels. And again, I'm seeing that word than in the problem. So than means switch the order. I'm writing this out just in case you're still having issues with the word than. We've talked about it in a few, I think we even talked about it in the first video. Definitely in the last video we talked about it. And so than means to switch the order. So I'm going to write the 3 at the end because the 3 is first in words, 3 at the end. More than would be plus. And finally, 7 times the number of nickels. So it says let lowercase n represent the number of nickels, write an expression for the number of dimes. So on the homework, you would type in 7n plus 3. You would not type in the D equals because it says expression. Expression means no equal sign, no less than sign, no greater than sign. It just means pluses and minuses. That's all. All right, so I think we are good on that section. If you are finding out, if you feel like you totally get this and you start the homework and you're like, why do I keep getting them wrong? Email me. I can look at how you typed them in and I can tell you right away, you know what, you were doing it correct. However, you typed it in a way the computer didn't understand. Or I could say, oh, maybe we need a little extra help in this section. So again, anytime you're finding yourself missing a lot of questions, just go ahead and let me know. Email me and we can work on it together. Oh man, I just really zoomed in on that one accidentally. Okay, so we have the last 2 sections. We're going to be talking about equations. So one, 2.3 is the subtraction and addition properties of equality. And so first we want to talk about what an equation is, what solutions are, and all that good stuff. So here in example A, we have an equation. This one's kind of complicated. Not really worried about that right now. Just looking at that equation, that's an equation because it has an equal sign. And we want to know if y equals 5 is a solution. So what we want to do is take our equation, and every time there's a y, I'm going to type a 5 instead. We've done this already with expressions. Now the only difference is we just have 2 sides. So again, every time I see a y, I'm going to type a 5. And I'm going to think about this as 2 expressions. So I'm going to look at the left side and do the order of operations. 2 times 5 is 10. plus 3 is 13. Look at the right side. 4 times 5 is 20, minus 7 is also 13. So those two sides are equal. In other words, we're asking ourselves, are those equal? And then we are saying, yes, they are. So yes, that is the solution. If the two sides were not equal, then no, we just say no. Okay, so how do we find a solution? And obviously they're not going to always just give us the solution. So we have to work on how to find it. And so here we're talking about the subtraction and addition properties, because all we're going to do is add or subtract to both sides of the equation. So for starters, I have a bunch of addition problems here. So it says x plus 6 equals 13. Something plus 6 equals 13. Now, you probably already figured out the answer just by me talking. However, I want to work through the steps, because as the problems get harder, you won't be able to just do them in your head quickly. So I want to make sure we all understand the steps. So here we have, we're adding 6 to x. So what I want to do to undo that is I'm going to subtract 6 from both sides. The reason we do that is because we get a zero pair. This positive 6 and the negative 6 equals 0. And that leaves just the x on the left-hand side. And then on the right, 13 minus 6 is 7. And there we go. Probably is just confirming what you thought the answer was already, but now we know for sure x equals 7. Okay, next up, I'm just looking at how much space we have. Okay, good. So what you can do, especially as the problems get more complicated, is you can check. And the way we would check x equals 7 is just to plug it in. 7 plus 6, does that equal 13? And we would say yes, perfect, we got it right. If you checked it and it did not equal 13, well, then we would have some more work to do. We'd have to go back and fix the problem. Okay, couple more. If you're feeling confident, go ahead and pause the video and work ahead of me and then come back and check. But if you are quite unsure still, then go ahead and follow along with me. So I'm going to see that I'm adding 17 to x. So to undo that, I'm going to subtract. Notice I said these were all addition equations because they are, but we're using the subtraction property because subtraction and addition are inverses. That means if I want to undo addition, I need to do subtraction. So again, we have this zero pair, 17 and negative 17, which gives us just x on the left-hand side, and then 37 minus 17 is 20. And finally, we have one last addition equation. You'll notice that the variable is on the right-hand side, and that is not a big deal. We can just leave it right there. We're still focusing on what we're doing to that variable. So in this problem, we are adding 8, and I want to undo that by subtracting 8 from both sides. So I can subtract 8, and I end up with y equaling, and then 40, take away 8, I get y equals 32 as the final answer. Any of these problems, you can check just like I did on part A and see that if you got the right answer or if you need to do the problem over. All right, so we're moving on to the addition property. That means we are dealing with subtraction equations, and to undo the subtraction, we need to do addition. So here, x minus 6, I'm going to add 6 this time. Whatever you do to the left side, you need to do to the right side. And so adding 6, 10 plus 6, I get 16. The negative 6 and the positive 6 cancel each other out. After we just did those last 3 problems, you'll see these are just the same 3 types of problems. The only difference is now I'm going to add 2 numbers instead of subtracting 2 numbers. So if you're getting the hang of it, as always, just pause the video, go on ahead, and see how you can do on your own, and then come back and watch the answers. All right, so here we are adding 100, or we are subtracting 100 from x, so I need to add 100 to both sides to cancel that out. By cancel, I mean that zero pair of positive 100 and negative 100. and I end up with x equaling 300 plus 100, which is 400. And notice I always have my equal signs. Well, that was supposed to be a dashed line, but that's okay. I'll draw a straight line. I always have my equal signs lined up, and that's just to make sure I keep stuff on the right over there, and I keep the left-hand stuff on the left side, and I don't lose my equal sign, and I don't accidentally cross things that aren't ready to be crossed. So finally, we have y minus 90. So what I'm going to do is I'm going to add 90 to both sides. Notice my zero pair, and that leaves us with y equals 100. Oh no, it doesn't. It goes over 100, so it's going to equal 201. Again, as best I can, and leaving those equal signs. They're a little crooked, but for the most part, I have my equal signs lined up. Let's see. Okay, so I think I'm going to kind of add at this slightly. I keep forgetting, so I'm going to give you this to pause the video. That way, if you are looking specifically for the break or change sections, it will be a little more obvious if you're fast forwarding. And we are back with the last section in this video, 2.4, identifying multiples and using divisibility tests. When we get into chapter 4, there's going to be a lot about fractions, a lot about common denominators and whatnot. So we're just barely starting that topic. Not fractions, but just multiples and divisibility. Divisibility tests are great when you are trying to check if something's prime or you're trying to break something apart. And so I want to start off with one that everyone knows, which is multiples of 2. So if something's a multiple of 2, it's an even number. That means it ends with the digit 0, 2, 4, 6, or 8. So if your number, or the number they're asking about, ends in one of those digits, then we will say yes, it's a multiple of 2. These are divisible. I'm using the word multiple here, but because multiplication and division are inverses of each other, they kind of go hand in hand. This is a test to see if I could divide it by 2. And I can always divide multiples of 2 by 2. So ends in 4, so I'm going to say yes. Ends in 0, so it's even. I'm going to say yes. Ends in 7, no. If it ends in 7, it's an odd number, and odd numbers are not multiples of 2. So I wrote out the numbers it needs to end with, but just as a reminder, multiples of 2 are even. All right, I'm going to skip 3 for a minute because 3 isn't as common of a rule. Not everybody knows this one. And I want to go to 5 and 10, and then we will come back to 3. So multiples of 5. What do multiples of 5 end in? That's going to end in 5 or 0. You'll notice I put all the same numbers for every single example because numbers have different multiples. So we can have some numbers on this list, they will be multiples of everything, and some won't be multiples of anything. And you'll notice on the homework, they will give you a specific number and they will say what this number is a multiple of what, and it'll give you a list, 2, 3, 5, 10. You'll have to choose from that list, and sometimes there'll be more than one answer. Okay, so looking at 3, again, we are looking at that last digit, the ones digit, and we are looking for it to be either 5 or 0. So 864 is a no, because it ends in 4. 10,860 is a yes, because it ends in 0. And 117 is a no, because it ends in 7. Number 4. Oh yeah, here's example 5. We're going to check all of the divisibility. Okay, for example 4, again, multiples of 10 is similar to 5. It ends in just 0, so check those last numbers Check that that ones place digit. No, because it's a 4. Yes, because it's a 0. No, because it's a 7. All right, the reason these are good is because you're going to be looking for divisibility. You're going to check if numbers are prime. You're going to be doing common denominators. You're going to be having a calculator. But if you don't know what to type in your calculator, it's going to take you forever to find these numbers. So it's good to know these rules so that way you can focus your search when you're looking in your calculator to come up with a prime factorization. Okay, so going back to problem 2, which was multiples of 3. Multiples of 3 has nothing to do with the last digit. It actually has to do with everything, all the digits. So the rule is that the sum of all digits is a multiple of 3. The sum of all digits is a multiple of 3. Sometimes I just read what I wrote twice just in case you can't quite read what I wrote. Okay, so let's look at A, 864. So I'm going to add up 8 plus 6 plus 4. Literally just add up the digits. That's all we're doing. 8 plus 6 is 14. Plus 4 more is 18. Is 18 a multiple of 3? Can you think of a number times 3 that equals 18? Yes. 6 times 3 equals 18. So the answer is yes to this problem. And that's it. You add up the digits, and then when you divide that number, this divides by 3. So, yep, the answer is yes. Okay, let's try that again. I'm not even going to write out the zeros because we don't need to add 0. 1, well, I'll just write it out so you get the idea. 1 plus 0 plus 8 plus 6 plus 0. You're adding up all the digits. 8 plus 6 is 14. 1 more than that is 15. 15 divided by 3 is, yep, that works. 15 divided by 3 is a whole number, so we're good to go. So that's not quite as fast as the other rules because I can't just literally look at it and say, oh, it ends in a 0 or anything like that. But it's still pretty fast. So here, last one, 117, 1 plus 1 plus 7. That adds up to 9. So the answer is yes. I just happened to pick 3 numbers that are multiples of 3, but you can test, you can just make up a number right now off the top of your head, and you'll see that sometimes it is not a multiple of 3. Okay, so let's look at 5, putting all these rules together. 5 and 6, perfect. We're gonna do 5 and 6, putting all these rules together. So this is more like what the homework will look like. It will give you one number, and it'll have you check for divisibility for all of the all of the rules that we have. Okay, so it ends in a 0. So that means it's divisible by 2, 0, divisible by 5, and divisible by 10. So far we just had to look at that one digit to know that it's divisible by those 3 numbers. Finally, I will add up 1 plus 6 plus 8 plus 0, 14, 15. Therefore, it is divisible by 3. So all 4 numbers work for this. So 3 of them were easy to check just by looking at that last number, and then 3 we had to write out. All right, last one on divisibility. It ends in a 3. That means 2 is out, 5 is out, and 10 is out because 3 is nowhere in those rules. So those 3 are no good. And let me check the last thing. 8 plus 1 plus 0 plus 3. 8 plus 1 is 9, plus 3 more is 12. Okay, so this one is divisible by 3. So if this was a homework problem, you would just check that one box. All right, so that is it for 2.4a. We are now going to finish up here. 2.4b is underneath this line. So if you want to head out and go do the for A, while those divisibility rules are still fresh, go ahead and do that. Or you can just stick with me for the next couple of minutes. We'll finish up this video and then you can do your homework then. It is up to you. Okay, find all factors of a number. So we're going to use our divisibility rule to find these factors. In other words, we want to know what makes up 34. So using the divisibility rules, I can see right off the bat that 2 goes into 34. So now that I know that it's 2, this is the point where I would use my calculator because I know I'm not wasting my time by doing 34 divisible, cannot talk, 34 divided by 2. So I do that and I get 17, and then there's nothing else that goes into 17. You could check it real quick, but those would be the answers, 2 and 17. We'll talk about prime numbers in just a second and when to stop. But here we have 100, and now 100 is going to be, oh, you know what? Okay, number, all right, hold on a second. Now this is right, the right answer here, but I just explained it in a way that we're actually not going to talk about to the next section. All right, finding all the factors of 34 means what are all the ways to multiply to 34? So I forgot the most obvious one is 1 times 34. We just listed 2 times 17, and then that's it. There's no more because 3 doesn't go into this, 5, 10, all of those numbers don't go into 34. So we are good to go. All right, so then I have 100, and 100 is good because we know a lot of those already just because of money. So I'm going to start a little higher because I think this list will be a little longer, but 100 is 1 times 100. And what I like to do is go in number order. So I started with 1, now I'm going to do 2. 2 times 100 is 50. You can check 3. But if you can add up those digits actually pretty quickly in your head. 1 plus 0 is not divisible by 3. Therefore, this is not going to work for 3. Let me just write that little note. 1 plus 0 equals 1. So not divisible by 3. Okay, so now I'm going to go to 4. 4 quarters in a dollar. 4 times 25. Next number is 5. 5 nickels, no, nickels are 5, so there's 20 nickels in a dollar. And then 6, 7, since this is all money related, it's pretty easy to just kind of go through and say, okay, next we need a dime. 10 times 10 is 100, and since the number repeats right there, we're not going to be able to find any more factors here. So those are all the factors, and probably on the homework, I forgot to look at this section in particular, but I'm sure you can figure it out, but it's probably going to be like 1, 2, 4, 5, 10, 20, 25, 50, and 100. So the answer will probably look like that rather than the way I wrote it. But the way I wrote it in blue is just a good way to organize your thoughts. Because again, you can use a calculator, but we want to practice using it in a smart way so that we're not wasting our time just constantly typing stuff into the calculator and maybe missing some stuff along the way. All right, so you've probably heard of prime numbers before. And so prime numbers, let me get a little space. Oh, I do not have very much space. So I will try to squeeze this in, maybe with a smaller pen. Let's see if I can do that. Okay, I'll see. Prime numbers, oh, that one's nice. They have exactly 2 factors. 1 and itself. Oh, I'm making a skinnier pen here. Okay, so what that means is if I looked at all the ways to multiply that number, I could only find 2 factors, 1 and itself. This number 34 is composite. It is not prime because it has 1, 2, 3, 4 factors, which is definitely more than the 2 needed for prime. The number 100 is also composite. You can see it has many more than 2 factors. And so the smallest prime number is the number 2. And then 3, 4 is not prime because you could say 1 times 4, or you could say 2 times 2. 5 is, 7 is, and sometimes people start to make up a pattern like, oh, it's only the odd numbers, but 9 doesn't work because 9 times 1 and 3 times 3. 11, 13, 17. And so you can just go on and on with that. But in other words, we can't divide it. And so when they're small, a lot of those numbers I just listed, in fact, probably all of those numbers I just listed, you already knew. You might have been confused about the number 1. And the reason the number 1 is not on the list is because it says exactly 2 factors. And if you think about how do you make the number 1, it's only 1 times 1. That's just the number 1. It doesn't have 2 factors. It only has 1 factor. So that would be an example of neither. So number 1 is not prime and it's not composite. Okay, but let's look how to check these using our divisibility rules. So right off the bat, I can see that 120, part B, ends in 0. Therefore, it is composite. So it is divisible by, now you could probably list a lot, but using our rules, we know it's divisible by 2. We know it's divisible by 10. It doesn't really matter what it's divisible by. As long as you know that there's a couple different numbers on that list, then we know that it is composite. So going back to 87, well, 87, that's kind of a big number. Most people don't have that memorized as prime or composite, but we can check. So first of all, it ends in a 7. So that means it's not divisible by 2, not divisible by 5, not divisible by 10. So I'm going to try my 3 trick. And when I look at the digits, 8 plus 7, I get 15, which is divisible by 3. So this is composite. I don't know what that number is off the top of my head, but now that I know it's divisible by 3, I could put it in a calculator. 87 divided by 3, and I get 29. And so I know that this number has multiple factors. 1 times 87, 2 times, no, not 2. 1 times 87, 3 times 29, and that might be it. I don't even care if that's it or if there's more. As long as I found a couple, more than 2, then it's composite. All right, so finally, C. We have the number 73. Check out that last digit is a 3. So we know it's not 2 or 5 or 10. I'm going to add 7 plus 3 equals 10. That is not divisible by 3. So it's a good chance that this number is composite. You can check a few more numbers. Maybe check 7 and 11 on your calculator real quick, but don't check all the numbers on your calculator. Use the divisibility rules and then just check a couple more, couple higher numbers. But once you check that, we find out that the only way to get 73 is 1 times 73. So this is in fact a prime number. All right, well, I am going to stop here. Oops, where did I go? Here I am. Ah, there I am. Oh, look, I was watching Hulu earlier. So I'm gonna stop here because it's the end of the section or the end of the module, but go ahead and get everything done, get the quizzes done, or the quiz done, the homework, all that good stuff, and I will be back for the chapter 3, the end of chapter 2 / chapter 3 video. All right, thanks for watching.